Welcome to Dewtime. I'm so glad you could join me today as we look into something that affects every single one of us, every single day: the weather. Have you ever wondered how we know if it's going to be sunny for your picnic, or if you need to grab an umbrella on your way out the door? That's all thanks to something called weather forecasting. It's the science of predicting what the atmosphere is going to do. Think of it like being a detective for the sky. We look for clues in the air, on the ground, and even from space to figure out what kind of weather is heading our way. It's a fascinating process that combines old-fashioned observation with some of the most powerful technology you can imagine. So, what exactly is weather forecasting? In simple terms, it is the process of using science and technology to predict the state of the atmosphere for a future time and a specific location. We are trying to answer some basic but very important questions. Will it be hot or cold? Will it be wet or dry? Will the wind be calm or gusty? These predictions aren't just guesses. They are based on a huge amount of information. We collect data about the current conditions, things like temperature, humidity, air pressure, and wind speed, and then use our understanding of how the atmosphere works to say what will happen next. It's a bit like a doctor diagnosing a patient, but our patient is the entire planet. The atmosphere is a giant, swirling ocean of air that is always moving and changing. It's a very complex system. Our job as weather forecasters is to make sense of all that movement. We want to give you a clear picture of what you can expect when you step outside. This isn't just about satisfying curiosity. Knowing the weather helps people make decisions, both big and small, that can keep them safe and make their lives easier. From a farmer deciding when to plant crops to a pilot planning a safe flight path, weather forecasts are a crucial tool. It's a responsibility we take very seriously every single day. Over the next few sections, we are going to pull back the curtain and show you exactly how we do it. We'll explore the amazing tools that help us see what the weather is doing right now, from satellites orbiting high above the Earth to radar systems that can peer inside a storm cloud. We will also talk about the powerful computer models that help us look into the future. It's a journey that will take us from the ground to the sky and back again. So, grab a cup of coffee, get comfortable, and let's dive into the incredible world of weather forecasting together. You'll see that there's a lot more to it than just looking out the window. So, why should you care about the weather forecast? Well, let me tell you, it's about much more than just deciding whether to wear shorts or pants. Accurate weather predictions are incredibly important for our safety and well-being. Think about severe weather events like hurricanes, tornadoes, or blizzards. Getting a warning just a few hours ahead of time can make all the difference. It gives families time to prepare, to secure their homes, and to move to a safe location if necessary. These warnings save lives, and that is the most important part of our job. We are always working to make these forecasts more accurate and to give people as much lead time as possible. Beyond just staying safe from dangerous storms, weather forecasts play a huge role in our daily lives and the economy. Imagine you're a farmer. Knowing when the first frost is coming can help you save your entire crop. Knowing if a long period of drought is on the way can help you plan for irrigation. Or think about the construction industry. Builders need to know if it's going to rain because they can't pour concrete in wet conditions. A good forecast helps them schedule their work efficiently, saving time and money. The same goes for so many other jobs, from shipping and fishing to event planning and tourism. The forecast also helps us plan our everyday activities and save resources. If you know it's going to be a very hot week, you might choose to run your air conditioner more efficiently, or plan indoor activities for your kids. If you know a big snowstorm is coming, you can go to the grocery store ahead of time and avoid the last-minute rush. Even something as simple as planning a family barbecue depends on knowing if the weather will cooperate. These small decisions add up, making our lives smoother and a little less stressful. It's all about having the information you need to make the best choices for you and your family. And let's not forget about energy. Power companies use weather forecasts to predict how much electricity people will need. On a hot summer day, they know that demand for air conditioning will be very high. On a cold winter night, the demand for heating will soar. By predicting these peaks in demand, they can make sure they have enough power ready to go, preventing blackouts. They also use wind forecasts to manage wind farms and solar forecasts to manage solar power plants. In this way, weather forecasting helps keep our lights on and our homes comfortable, all while helping to manage our energy resources wisely. One of the most powerful tools we have for watching the weather is the weather satellite. These incredible machines are our eyes in the sky, constantly orbiting the Earth and sending back pictures of what's happening down below. Think of them as giant cameras floating in space, giving us the big picture view of weather systems. Before we had satellites, we could only see storms once they were close to land. Now, we can track a hurricane from the moment it starts to form as a small disturbance over the warm ocean waters of the Atlantic, thousands of miles away. This gives us days, not hours, to prepare for its arrival. There are two main types of weather satellites that we use. The first kind is called a geostationary satellite. These satellites orbit about 22,000 miles above the Earth's equator. At that specific altitude, they move at the same speed that the Earth is spinning. This means they stay parked over the same spot on the planet all the time. From this fixed position, they can take continuous pictures of the same area, like the entire United States. This allows us to watch weather systems like storm clouds and fronts as they move and develop in real time. It's like watching a movie of the atmosphere, which is incredibly useful for short-term forecasting. The second type is the polar orbiting satellite. These satellites fly much closer to the Earth, usually only about 500 miles up. Instead of staying in one spot, they travel in a path that takes them over the North and South poles. As the Earth spins beneath them, these satellites are able to scan the entire planet, piece by piece, like you might mow a lawn in strips. They provide incredibly detailed images of the atmosphere, the oceans, and the land. Because they are so much closer, they can see smaller features and collect very precise data on things like temperature and moisture at different levels of the atmosphere. So, what are these satellites actually looking at? They do more than just take regular pictures like your phone camera. They can see in different kinds of light, including infrared light. This allows them to see clouds even at night. The infrared images also tell us the temperature of the cloud tops. Colder, higher cloud tops often mean a stronger storm with more potential for heavy rain or severe weather. Satellites can also measure sea surface temperatures, track smoke from wildfires, and even monitor snow and ice cover. All of this information is fed into our computer models to give us a complete picture of the Earth's weather system. While satellites give us a great view from above, we need another tool to see what's happening inside the storms. That's where radar comes in. The word radar stands for radio detection and ranging. It works by sending out a beam of radio waves from a large antenna, which is usually protected by a big round dome that looks like a giant golf ball. These radio waves travel through the air until they hit something like raindrops, snowflakes, or hailstones. When the beam hits these objects, a small amount of the energy bounces back to the radar dish, just like an echo. The radar system is very smart. By measuring how long it takes for the echo to come back, it can calculate how far away the rain or snow is. The stronger the returning echo, the heavier the precipitation is. This is why you see different colors on a radar map on your TV or phone app. Light green might mean light rain, while yellow, orange, and red usually mean heavier rain. We can even see purple or white, which often indicates very intense rain and possibly hail. This allows us to see exactly where it's raining, how hard it's raining, and in which direction the storm is moving. But modern radar, called Doppler radar, can do even more. It can tell us not only where the rain is, but also how it is moving. It does this by using something called the Doppler effect, which you might have experienced with sound. Think about how the siren of an ambulance sounds higher as it comes toward you and lower as it moves away. The same principle applies to the radio waves from the radar. By measuring the change in the frequency of the returning echoes, the radar can tell if the raindrops are moving toward it or away from it. This is incredibly important for detecting severe weather. This ability to see the motion within a storm is what helps us issue tornado warnings. Tornadoes form from rotating thunderstorms called supercells. On a Doppler radar screen, we can see this rotation as an area where winds are rapidly moving toward the radar, right next to an area where winds are rapidly moving away. We call this a velocity couplet or a hook echo, and it is a very strong sign that a tornado could be forming. This allows us to warn people in the path of the storm to take cover, often 15 to 20 minutes before a tornado touches down. Radar is truly a life-saving technology. Satellites and radar give us a fantastic view of what's happening up in the atmosphere, but we also need to know what's going on right here on the ground. That's the job of weather stations. You've probably seen them before, maybe at an airport or in a field. They are collections of instruments that measure the weather conditions at a specific location. These stations form a huge network, with thousands of them located all over the world, on land and even on ships and buoys at sea. Each one acts as a little weather reporter, constantly sending us updates on what's happening in its neighborhood. What exactly do these stations measure? Well, they collect the basic information that forms the foundation of any weather forecast. One of the most important instruments is the thermometer, which measures the air temperature. Another is the barometer, which measures air pressure. Falling air pressure often means a storm is approaching, while rising pressure usually signals clearing skies and fair weather. They also have an anemometer, which looks like a set of spinning cups, to measure wind speed, and a wind vane, which is like an arrow, to show the wind direction. A hygrometer measures the humidity, which is the amount of moisture in the air. All of this data is collected automatically, 24 hours a day, 7 days a week. The information is then sent to central weather offices like the National Weather Service, where forecasters can analyze it. By looking at the data from all the different stations, we can create a detailed map of the current weather conditions across the country. We can see where the warm air is, where the cold air is, and where the wind is blowing from. This surface map is a critical starting point for making a forecast. It helps us identify weather fronts, which are the boundaries between different air masses, and these fronts are often where interesting weather happens. In addition to these automated stations, we also get information from weather balloons. Twice a day, at the same time all around the world, weather balloons are launched into the sky. These balloons carry a small instrument package called a radiosonde. As the balloon rises through the atmosphere, sometimes as high as 20 miles up, the radiosonde measures the temperature, humidity, and air pressure at different altitudes. It also sends back information on the wind speed and direction. This gives us a vertical slice of the atmosphere, showing us what's happening at different levels. This upper air data is essential for the computer models that predict the weather. So we've gathered all this incredible data from satellites, radar, weather stations, and balloons, but how do we turn all those numbers into a 5-day forecast? That's where some of the most powerful computers on Earth come into play. These supercomputers are the real brains of the modern weather forecasting operation. They are capable of performing trillions of calculations every single second. We need that much power because the Earth's atmosphere is incredibly complex, and predicting its behavior involves solving a lot of very complicated mathematical equations. These equations describe the physics of how the air moves, heats up, and cools down. These computers run what we call weather models. A weather model is essentially a computer program that simulates the atmosphere. To start, we feed the model all the current weather data we have, the temperature, pressure, wind, and humidity from all over the globe. The model divides the entire atmosphere into a giant three-dimensional grid, like a huge stack of checkerboards. Each box in the grid is assigned the current weather conditions for that specific location and altitude. The model then uses the laws of physics to calculate how the weather in each box will change over the next few minutes. Once it calculates the new conditions for every box, it uses that result as the starting point for the next step. It repeats this process over and over again, stepping forward in time, minute by minute, hour by hour, and day by day. By doing this, the model can generate a forecast for what the weather will look like several days into the future. It creates maps that show us predicted temperature, pressure, wind, and precipitation. There are many different weather models, some that are better for predicting large-scale patterns and others that are better for small-scale events like thunderstorms. As a forecaster, my job is not just to read what one computer model says. I look at the output from several different models. Sometimes they all agree, which gives us high confidence in the forecast. Other times, the models might show different outcomes, especially for forecasts that are many days away. In that case, I use my experience and knowledge of meteorology to decide which model is likely the most accurate, or I might create a forecast that is a blend of the different possibilities. The computers provide the guidance, but it still takes a human forecaster to interpret that guidance and create a forecast that is clear and useful for you. When you check the weather to decide what to wear tomorrow, or if you need to take an umbrella, you are using a short-term forecast. This type of forecast usually covers the next 48 hours to about a week. This is the time frame where our predictions are the most accurate and reliable. Why is that? It's because we have a very good picture of the current state of the atmosphere. The weather we will experience tomorrow is closely linked to the weather systems that are already formed and moving across the map today. We can track these systems with a high degree of confidence using our satellites and radar. For a short-term forecast, we rely heavily on the high-resolution computer models. These models are very detailed and can predict weather for specific locations, sometimes down to a neighborhood level. They are especially good at predicting the timing of events, like when a line of thunderstorms will move through your town or when the rain will change over to snow. As forecasters, we look at these models to understand the movement of high and low pressure systems, the location of weather fronts, and the amount of moisture available in the atmosphere. This helps us build a detailed hour-by-hour forecast for the next couple of days. A great example of how this helps is planning for a commute. If the forecast says a snowstorm will start around 4 p.m., you might decide to leave work a little early to avoid the worst of the traffic and slick roads. Or, if you have a child's soccer game on Saturday morning, the forecast can tell you if you need to pack rain gear or sunscreen. These everyday decisions are made easier and safer with reliable short-term forecasts. It's about giving you the information you need to plan your day and stay out of harm's way, whether it's a major storm or just a pop-up afternoon shower. We also use a technique called nowcasting for the very near future, like the next 0 to 6 hours. This is where radar is king. By watching the movement and development of storms on radar, we can make very specific predictions about what will happen in the next few minutes to hours. For example, we can say, the heavy rain you see to your west will arrive in your town in about 25 minutes. This is extremely useful for outdoor events, aviation, and for issuing severe thunderstorm or flash flood warnings. It's the most immediate and often the most detailed type of forecasting we do. While short-term forecasts are for our daily plans, sometimes we need to look further ahead. This is where long-term forecasting comes in. This type of forecast looks at time periods ranging from a week to several months or even seasons in advance. Instead of telling you the exact temperature or if it will rain on a specific day, a long-term forecast talks about general trends. For example, it might predict that the upcoming winter will be colder and snowier than average, or that the summer will be hotter and drier than usual for a particular region. These outlooks are about probabilities and overall patterns. Making these long-range predictions is much more challenging than forecasting for tomorrow. The atmosphere is a chaotic system, meaning that tiny, unpredictable changes today can lead to huge, different outcomes weeks from now. This is sometimes called the butterfly effect. Because of this, we can't use the same detailed models we use for short-term forecasts to predict the weather on, say, Christmas Day when it's still July. The small errors in the initial data would grow so large over time that the specific daily forecast would be meaningless. So, we have to use a different approach. For long-term forecasts, we look at very large-scale patterns in the climate system that change slowly over time. One of the most important of these is the El Niño Southern Oscillation, or ENSO. This is a pattern of warming and cooling of the ocean water in the tropical Pacific Ocean. Whether we are in an El Niño phase, warmer water, or a La Niña phase, cooler water, has a huge impact on weather patterns all over the world. By knowing the current state of ENSO, we can make an educated guess about what the upcoming season might look like in different parts of the globe. We also look at other factors like ocean temperatures in other parts of the world and the amount of sea ice in the Arctic. These long-range outlooks are extremely valuable for many industries and for government planning. For example, a forecast for a dry summer can help water managers plan for water conservation measures. A prediction for an active hurricane season can prompt coastal communities and emergency managers to prepare their resources and plans well in advance. For the energy sector, knowing if a winter is likely to be unusually cold helps them plan for natural gas supplies. While these forecasts are not perfect, they provide crucial guidance that helps us prepare for the future and manage our resources more wisely on a larger scale. As we've seen, weather forecasting is a complex and fascinating science. It's a blend of cutting-edge technology and human expertise, all working together to solve the puzzle of the atmosphere. From the satellites watching from space to the supercomputers crunching numbers on the ground, every piece of the process is designed to give you the most accurate and useful information possible. It's a global effort, with scientists and forecasters from all over the world sharing data and knowledge to improve our predictions. We are constantly learning more about how the atmosphere works, and our forecasts are getting better all the time. The importance of this work touches every aspect of our lives. First and foremost, it's about public safety. Timely warnings for tornadoes, hurricanes, floods, and winter storms give people the chance to protect themselves and their families. This is the most critical service we provide, and it is the driving force behind our constant push for improvement. Every life saved and every injury prevented is a testament to the value of accurate weather forecasting. It allows us to be proactive instead of reactive in the face of nature's most powerful forces, and that makes our communities more resilient. Beyond safety, weather forecasting is a vital engine for our economy. Nearly every industry, from agriculture to aviation, from construction to retail, is affected by the weather. Good forecasts help businesses operate more efficiently, reduce risks, and save money. This leads to a stronger and more stable economy for everyone. It helps ensure that food gets to our tables, that goods can be shipped across the country, and that we have the energy we need to power our homes and businesses. The economic impact of weather forecasting is enormous, even if it often happens behind the scenes. Ultimately, weather forecasting matters because the weather itself is a fundamental part of our shared human experience. It dictates our plans, inspires our conversations, and colors our world. Whether you're planning a vacation, coaching a little league team, tending to your garden, or just stepping out for a walk, the weather is your constant companion. Having a reliable guide to what it might do next empowers us to make smarter, safer, and better decisions every single day. So next time you check the forecast, remember the incredible science and dedicated people working around the clock to bring you that little piece of the future.